Our first speaker is Professor Susaki from the Department of Biochemistry and Systems Biomedicine at Juntendo University Graduate School of Medicine. So if you're ready to go, over to you.
So thank you very much for the kind introduction, and welcome to Japan, and welcome to the online participant. And so I'm Susaki at Juntendo University based on Tokyo. And we are long been working on the tissue clearing field. And today I'd like to talk about our latest works regarding the microscopy devices that's to facilitate the tissue clearing usage in the many research fields. So as you may know, the tissue clearing is one of the old and new histopathological techniques. And we can see the oldest literatures over the 100 years ago. But particularly in recent years, there are many tissue clearing protocols are reported. I didn't count all of them, but actually dozens of protocols are reported. And they are basically categorized 3 or 4 groups based on their reagent types or methods. Like, some of them are really kind of sophisticated, but a little bit tricky way to make tissue cleared. So our tissue clearing method named cubic is categorized in the hydrophilic reagent based method. We are using our aqueous solutions for two type of aqueous solutions for clearing. So here is one example we performed for whole marmoset infant body. So as you can see here, so not only the soft tissues but also the bone, as well as any other tissues totally cleared after the treatment of our reagent. So in recent years, not only our techniques, but also several other techniques provide such a really efficient method, the protocol for making the complete entire tissue to be cleared. So the light sheet microscopy is one of the best solutions to take the whole tissue images in 3D. So this microscopy illuminate the sheet-shaped lasers from the side of the cleared samples, and then the illuminated plane can be obtained from the vertical side with the 2D CMOS camera. So you can collect all of the these stacks throughout the samples in a very high throughput manner. So here's an example we collected by our own light sheet microscopy system. Here we stained 3 neural cell type markers in the different combinations, or we observe the fluorescent protein expression together with the immunostaining signals. So such multimodal imaging, labeling and imaging is one of the advantage of our cubic reagent techniques. But there are many obstacles to democratize these cutting edge techniques in the many research fields. So one of the obvious obstacle is the microscopy itself, because there are several commercial light sheet microscopy for clear samples, but they are really expensive. And also, if you want to install your own light sheet microscopy to build from the scratch, you need to learn a lot about the microscopy systems and how to build it and how to construct it, right? But so we realized that there is huge demand to install such a very low expertise and very low cost light sheet system to use the tissue clearing techniques in the end user driven research. So we recently designed the descSPIM, which is one of the solutions we thought. So this microscopy was constructed only over the up to 100 parts. And the important feature is this is a really cost efficient. It's up to the 20K to 50K US dollars. And also you can build up all of the stuffs within 1 day based on the construction books we provided. So what you are doing is you just send the path list to the Soul Lab, and then got several boxes, and then opened it up. This is actually the taking the several hours to open and extract all of the parts from the box. But yeah, actually this type of microscopy can be built up within 1 day for most of the end users. So due to in spite of these very basic systems, this microscopy has enough the capability to acquire the whole clear samples with the single cell resolution. So the X-ray resolution is almost at 3.5 micrometers, and the Z resolution is a little bit elongated, but it still provides a single cell resolution. And when we constructed the 3D images, so you can see the very nice 3D features throughout the whole tissue images. And the important point is, so we could collect all the stacks within the 80 seconds. So it's a very rapid, and so that's why we believe the combination of tissue clearing and light seed is the best solution for such purposes. And a little bit advanced applications, we collected several stacks throughout a little bit large samples, the whole mouse brain, and then combined all of them with registration and stitching. So and then we did observe the whole mouse brain with single cell resolution. So a little bit tricky applications, but in principle, our devices provide such a opportunity. So here's another application. We observed the whole tumor mass with experimentally, extracted from the mouse, and then we labeled the whole tumor mass with the vessel structures, nuclei, as well as the anti-cancer drugs, the antibody drugs, and then we observed the distributions of anti-cancer drugs throughout the whole tissue mass or tumor mass. So not only some areas we observed really nice distributions of drugs, but in other areas the poor distribution has been also observed. So suggesting there's reflecting the tumor microenvironment in this tissue. So this result actually ignited us our new research to modulate the structures and functions of the tumor microenvironment to improve the drug distributions. So here is another example. We just had a nice talk about digital pathology, but we are now trying to the 3D digital pathology. And here's the applications of such things. So we stain the whole tumor mass with the nuclear stain propylium iodide, as well as the non-specific protein staining. And then the color has been converted to the fluorescent colors, to the hematoxylin and the elgin type colors. And then we successfully observed all of the 3D stacks throughout the tumor mass. So this is actually the kind of the practice of the 3D pathologies. And now we are developing the new microscopy based on our descSPIM system for more suitable for the clinical 3D pathology setting. So this microscopy is now being provided under the support of the ABIS, and we've already had the the user meetings several times to teach and how to build up and how to use this device together with the tissue clearing. So many people has been learned a lot, and then all of the resources already opened in our GitHub website. So and also we published some of the Japanese textbooks, and one of them are edited by me. And the people in these rooms has already actually contributed to the publication. So there are really nice textbooks to facilitate these techniques. And actually, many researchers has already been installed our systems and start to use it. And so we ask them to provide the pictures and then kindly give us a lot of nice pictures of their systems. And actually, these systems are working, already working, and they collect a bunch of samples throughout not only the mouse tissues, but also the rats, fish, and embryos or something like that. So this suggests this microscopy provides huge opportunities to use in any research field, biology and medicine. So in summary, we developed the descSPIM, the low cost and the low expertise microscopy that facilitates end user research, end user driven research using tissue clearing techniques. This, the descSPIM actually achieves the cellular resolution, the multicolor imaging, and also this is open source. So that's why descSPIM facilitate the 3D imaging applications in many research fields with tissue clearing techniques. So here is the main contributors, our laboratory and our the collaborators. And also I want to acknowledge all of the authors in our latest publications regarding the descSPIM. Yeah, they kindly provided all the pictures and data to show the possibility of this device. And of course, this project is partly supported by Avis and Kakenshi. So thank you very much.